Unit 1A, Lesson 4. In this lesson, you're going to work with solving linear equations. This is something you did in middle school, so it should be a quick review of those ideas. To start out the lesson, we're going to talk about some basic vocabulary. An algebraic expression, simply an expression consisting of numbers and variables. An algebraic equation is two algebraic expressions set equal to each other. And then the last term is like terms. These are terms that have the same variable and exponent. Now we're going to review PEMDAS, P-E-M-D-A-S. You probably heard the expression, please excuse my dear Aunt Sally. This tells us the order of operations. Okay. When we're going through simplifying an expression, we're always going to do parentheses first. Then we're going to do exponents. Then multiplication and division, they have the same ranking. They have the same status. So the one we perform first is the one that occurs first when going from left to right. And then we have addition and subtraction. That's the same idea. They have the same ranking, the same status. So whichever one occurs first going left to right is the one we're going to use first. When we're trying to simplify an expression, that is when we use the order of operations. We start with parentheses and go down to addition and subtraction. If we're trying to solve for a variable, if we're trying to isolate a variable, then we're going to use the inverse order of operations. We start with addition and subtraction and go to parentheses. So that's an idea you need to really understand. If we're simplifying, we use the order of operations. If we're solving, isolating a variable, then we're going to use the inverse order of operations. Now we're going to go through a few examples of solving an equation for an indicated variable. So if we're trying to solve for or isolate a variable, we're going to use the inverse order of operations. So we have 2x minus 7 equal to 13. We're trying to solve for that value of x. We want to isolate x by itself. So first we have to look for addition and subtraction, then multiplication and division, and then exponents and parentheses if we need to. So going from left to right, I see we have subtraction. We have negative 7. So we have to take care of that first by adding 7 to both sides of the equation. What we do to one side of the equation, we must do to the other, which is going to leave us with 2x on the left side of the equation equal to 13 plus 7, 20. Now the next step, to isolate x by itself, if we're multiplying by 2, we need to divide by 2. If we divide by 2 on the left, we need to divide by 2 on the right, which leaves us with x equal to 20 divided by 2 is 10. So solving or isolating a variable, use the inverse order of operations. The next example, we have 3 times the quantity x minus 5, then plus 8 equal to 29. Again, we want to solve, isolate x by itself using the inverse order of operations. So first, looking for addition or subtraction going left to right. We see there is subtraction. We're subtracting 5, but that occurs within a set of parentheses, so we have to leave that for last. So we go to plus 8. We have to take care of that positive 8, move it to the other side by subtracting 8, which is going to leave us with 3 times the quantity of x minus 5 equal to 29 minus 8 is 21. Now going left to right, we see we have multiplication. We have 3 times this quantity. So to get rid of that 3, we need to divide by 3, which means we must divide the right side by 3 as well. So we have x minus 5 equal to 21 divided by 3 is 7. Last thing to get x isolated by itself is to add 5 to both sides of the equation. So now we're left with x equal to 7 plus 5 is 12. So going through isolating, solving for a variable using the inverse order of operations. The third example, we have 2x plus 3x minus 7 equal to 4x. In this problem, we have to use the third vocabulary term we talked about, like terms. Like terms are terms that have the same variable raised to the same exponent. So we see we have an x to the first, an x to the first, and an x to the first. So all of those terms, 2x, 3x, and 4x, those are like terms. So if we're going to go through and isolate our variable by itself, we have to combine those terms together. So the first thing we can do, we're going to have to use multiple steps, is combine our like terms on the left side of the equation. So 2x plus 3x is going to be 5x minus 7 equal to 4x. Okay. Now we have a 5x and a 4x. Those are like terms. We need to get those together. We could subtract 5x to the other side of the equation, or we could subtract 4x to this side of the equation. I'm going to choose to subtract 4x to this side of the equation. That way I'm going to keep the coefficient in front of my variable positive. So we subtract 4x, 5x minus 4x is just going to be 1x, or just x. X minus 7 equal to 0. Now the last step to get x isolated by itself is to move the 7 to the other side. So we add 7 to both sides of the equation, which leaves us with x equal to 7. So combine like terms, then isolate the variable by itself. The last example we're going to go through, we have 11 equal to 3 times the quantity of x plus 4, all divided by 2, and then minus 1. So we want to go through and isolate for our variable x. The first thing we should do in this problem is get rid of this negative 1 we have at the end of our equation. Okay, so we get rid of that by adding 1 to both sides of the equation, which leaves us with 12 equal to the quantity of 3 times x plus 4, all divided by 2. Now, since on the right side of this equation, we're dividing this whole expression by 2, we should get rid of that fraction. And if we're dividing by 2, the inverse operation of that would be multiplying by 2. So we're going to multiply by 2 to both sides of the equation. So 2 times 12, we get 24, equal to 3 times the quantity of x plus 4. Now we need to get rid of that multiplication, so we divide both sides by 3. 24 divided by 3 is 8, so we have 8 equal to x plus 4. The last step would be to subtract 4 to the other side of the equation to isolate our variable x. So we get 4 equal to x. So we went through, used the inverse order of operations to isolate our variable. In this lesson, we discussed a few vocabulary terms. Make sure you understand those definitions. And then we talked about the difference between simplifying an expression and solving for a variable. When simplifying an expression, you use the order of operations. When solving or isolating a variable, you want to use the inverse order of operations.